This question gives us a really important piece of free information. It tells us that x is the average of p, r, and s. It also tells us that p, r, and s are consecutive integers. So these are two very important pieces of information. It probably would be a good idea to just use the dictionary definition of average and say that x equals p plus r plus s divided by 3. And if you wanted to simplify that a little bit, you maybe multiply both sides by 3 and say that 3x equals the sum p plus r plus s. Now, in that context, statement 1 is very surprising because statement 1 almost seems like it's contradicting the free info. We had inferred from the free info that 3x is equal to p plus r plus s, but statement 1 tells us that actually 2x is equal to p plus r plus s. And we know that the statements are not allowed to lie. And we also know that the free info is not allowed to lie. So how do we make sense of this? How could it be possible that 2x and 3x are each equal to the same thing? Well, it must mean that 2x and 3x is the same. But under what circumstances would that be true, that 2x equals 3x? Well, you could subtract 2x from both sides of the equation and you'd end up with x equals 0. And indeed, that is the only way that 2x and 3x could be the same. So statement 1 is really telling us that x is 0. What would that mean for p, r, and s? If their average is 0 and we know that they're consecutive integers, the only way that works out is if p, r, and s are -1, 0, and 1. The question was just asking for the value of x, and statement 1 implies that x is 0. And when you look at statement 2, it seems that it's kind of giving us the same information that statement 1 gave us. Right? Statement 1 implied that p, r, and s are -1, 0, and 1, and statement 2 also implies that p, r, and s must be -1, 0, and 1, because that's the only set of consecutive integers whose sum would be 0. Which means that these statements are inferentially equivalent, meaning statement 1 implies statement 2 and statement 2 implies statement 1. So in the second section of my book, which you could actually read for free on quantreasoning.com, I explain why if the statements are inferentially equivalent, you can automatically eliminate answer choices A, B, and C without even reading the question. This has to be either D or E. Now we already decided that statement 1 was sufficient on its own, so the correct answer must be D. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.